Welcome to Rob. Rob's mission in his career has always been to help workers of the world breathe clean air. He does this by educating, advising, and supporting companies in solving their particular air quality challenges. He believes in using applied science in both local exhaust and local control ventilation design, and such tools as 3D modeling and what we're about to talk about, computational fluid dynamics, to achieve a desired health-focused results. He's over 45 years in the local exhaust and industrial ventilation industry. He's been educated at Sheridan College in a mechanical engineering technology program, and through the ACGIH industrial ventilation, member also of AIHA, who we just heard from, ACGIH, ASHRAE, NAFA, and OHAO, our own Occupational Hygiene Association of Ontario, where we first heard Rob speak on this topic of computational fluid dynamics. So over to you, Rob.
So thank you, Kimberly. I appreciate it. Thank you to everybody attending today. We really appreciate the opportunity to pass along a little knowledge. And a special shout out to Larry and Ken. That was a great presentation, guys. It's a complex journey here, and I just wanted to compliment you on that. That was great. I'm going to dig into a little bit of that complexity on the engineering control side today. I'm coming from you in the state of New Jersey, actually, coming back from the AIHA conference.
You're international too.
The role of CFD. So the role of CFD in local exhaust ventilation and local control ventilation is what we're going to talk about. Real quickly here, what is CFD? It stands for Computational Fluid Dynamics. In a really simple way, it's using computers to predict the movement of air and fluids. What is LEV? Some of you may know. LEV is local exhaust ventilation, meaning we're pulling or we're extracting and we're contaminants, airborne contaminants, we're moving them away from the breathing zone. And then, apologies for this computational fluid dynamic title here. What is local control ventilation? Local control ventilation is very similar to local exhaust ventilation, except it's using push air, or we're blowing purified air through the breathing zone to protect the breathing zone, creating what we're calling a clean to less clean air pattern. And some people are also calling that directional flow or directional airflow. We're going to talk a little bit about it. This is just a slide to help everybody understand where it's coming from. We've been doing this a long time. ACGIH has also, and they have a special section dedicated to talking about air patterns. They call it Air Patterns Matter. Why are we here? We're here to just explain to you the effectiveness of CFD, or computational fluid dynamics, in predicting the air pattern. So this is a little image on the right. I hope you guys all can see it, from an operating room. So local control ventilation in an operating room has been practiced for years. There's a little image of it, and you can fairly accurately predict how that air is going to move through the areas you're trying to protect. You can also use smoke candles, velocity meters, and then we're proposing CFD. Why is this important? One of the reasons, ventilation systems, how can I put this politely? They haven't really been designed for human health. So our goal is to show people how CFD can overcome some misinformation and some commercial forces at play, and then help with the lack of information and show everybody how we're going to move the air and what makes sense. A little bit further along here, CFD also has some great tertiary benefits. One of my biggest favorites is energy savings. By moving the air a little more laminar, a little more predictively, you need less air and you'll need less energy. You can also reduce noise. You can increase worker comfort, and overall, in the long run, it's the most cost-effective way to do it. We're going to talk a little bit about how air comes out of filtration units. I don't want to minimize the need for dilution air or fresh air. Some of our slides show totally recirculated air, but remember, fresh air is always preferred. Windows are my personal favorite. So here you see in this picture, you see a portable air cleaner. The colors indicate velocity. So that's a 500 feet per minute is the red lines. So I'm going to just turn on the video here. And you can see how that air in the room, if the air is pointing straight up, it just kind of has a pretty good mixing effect of sharing those viruses all around the room. And that's why we tag that as not ideal. Still better than nothing, of course. Little discussion on some of the math behind the CFD. And so it uses a Navier-Stokes equation, fairly complicated. I don't really want to get into it today because we're on a limited time, but that's a little bit of understanding on where the math comes from. I'm going to roll through this presentation fairly quickly. There's about 70 slides here. So I'm going to roll through them quickly. If you guys got questions afterwards, no problem. And then we're going to make this presentation available to anybody who would like to have it. So there's two benefits. We're trying to break it out here. The role of CFD in local exhaust ventilation, and that's where we're pulling air or sucking air. We can talk a little bit about that, but that's kind of where we see it. And then local control ventilation, and that's over here where we're pushing air through the breathing zone or where the contaminant is created. I put this little slide here for noise effect. Big challenge in getting all of these air cleaners working. We really got to pay attention to things like noise. Obviously, we want to put purified air in the breathing zone. We want to have improved dilution. At the same time, when we're doing dilution ventilation, we want to minimize the K factor. That's a key component of this whole thing when calculating required air changes per hour. We want to minimize the contaminant migration, avoid comfort issues like dry eyes and chills, minimize worker position effect where contaminants can, if the air is moving too quickly, it can return and the operators or workers can breathe the contaminant in, noise reduction, and energy efficiency. I'm going to skip this slide here. This is just discussion on some other different types of ventilation methods, mixing, displacement, dilution, and directional flow. I'm going to skip this just quickly, but I just want to really bring everybody's attention to the fact that when we're dealing with efficiency, there's a tendency to think about the efficiency level of the filter. And that is important, but it's also just as important to make sure we're talking about capture efficiency, overall system efficiency. So these are some places where CFD is really it's really great. You can use it in reception rooms, workstations in offices, boardrooms, shop floor. There's a tertiary benefit there for heat stress. Medical offices, dental offices, waiting rooms, retirement homes, fitness clubs, restaurants, bars, meeting rooms, and lunchrooms and cafeterias. And you can see in this picture, we're talking about blowing purified air right at the occupants or workers. I believe people have seen this slide before, but it just talks a little bit about the spread. And once again, my favorite here, opening windows whenever possible. Obviously, sometimes that air outside is not clean enough, so we might have to filter it. Little quick chat about older buildings. It really can be done in older buildings. I know a lot of people are challenged by this, but you can combine some fresh air with some recirculated air, just making sure we filter it. I'm going to skip this. It is important, but I think it was Ken. Ken, you referred to this complex journey in the ventilation side. One of the reasons why it's very complex is there's a lot of people involved, electrical engineers, sometimes structural project managers, so on. You can see the little list here. We made a little pie chart for you. Skip on through here. Those are some of the roles. I'm just going to go back there. There's some roles of different people who might be involved in what they do at different stages of a ventilation process. And now we get into some of the stuff that you guys probably are interested in. So we ran some case studies and we did some tests. The tests we did were for particulate matter PM10, 2.5, and a little bit of PM1, particle concentrations, noise level, temperature, velocity, and we've subsequently followed up with energy. It's not on the list here. I don't know if we have it tagged. This is the equipment that we use, some dust track 2 unit, a MET1 unit, Dwyer velocity meter. Right now, during these tests, we just used the NIOSH sound level app. In the future, we're following all these applications up and case studies up using getting some more octave frequency readings. Here are the 4 case studies. Just watching my time here. Okay, we're pretty good. So we have a fitness studio and exercise using exercise bikes. We have a boardroom, a very simple boardroom table with about 4 people sitting around it, a reception with 2 people, and a curling club where they did a bar setting, and they also did the ice setting, ice pad. So here is our 4 applications, just in a kind of a quick intro. Get rid of that. Sorry about that. And there you just see a little bit of detail on the project. This is where we did it. There's your case study. Just going to click on a little video so everybody can understand. You can see the directional flow nozzles above the fitness members here. Here's a quick, we're going to show you on the next slide, but you can see once again on our CFD, the colors are denoting velocity in feet per minute. Here in the fitness club, the patrons were much happier with a little higher velocity than normal. So we set theirs at about 90 feet per minute. In most other settings, we're finding people are happier with below 50, somewhere between 25 and 50 feet per minute. Just run this video so you can kind of see how it all works. So there's a very simple CFD simulation showing purified air being blown at the patron while working out. So you can see some of the numbers, the big numbers here. The total particle count went down by 44%. In the P1.0, PM 1.0 readings, we went down by 33%, 2.5, we were down by 37, and so on. And the sound level in this application was about 10.6% higher than off. These guys did want it to be a little higher speed, so that's where they were coming from. Typical observations, there was no adverse effect. The members overall liked it. They liked exercising in a masks-free method. Everybody understood that if they were affected or they were symptomatic in any way, it was going to be blown to other people, but they all felt that it was better than what they had, and the noise levels were quite low, and yeah, everything went quite nicely there. We talked about that already. And so here's another one, a reception area. Just see how it's mounted. These units, in this case, was extracting the air off the floor, filtering it to H14 filtration level, up and over, and down into the operator's breathing zones. Here's our little CFD model showing that. These guys also wanted, I'm just going to go back to that slide for a second. They also wanted really high velocities. It was the air conditioning wasn't working when we were testing, and so they had the velocities cranked quite high. Thank you, Kimberly. This is a simple little CFD just showing very quickly how that air rolls through the breathing zone. Here's some of the reductions. You can see the total particle count went down by 86%. PM1 was almost, there wasn't a lot in the facility in the first place, but it was reduced to 0. 2.5, the large reduction. 10, 68%. So some really good stuff. Obviously, it was noisier than before, but people were quite happy with it. I'll just skip through some of these. Talked about those. So here's another application where it's in a boardroom and the air is being blown in above the table, pushed down through the breathing zone, and then once again picked up off the floor. There's a little drawing of the equipment used. And here is our CFD simulation. I hope I didn't miss it before, but this is where the air on all of this equipment is being extracted following the clean to less clean guidelines by CDC and ACGIH. See a little bit of how this runs. So there's an exhalation, another exhalation, and you can see when the unit's turned on what it does to the exhalation. Show that again so people can kind of get a grasp of it. And the unit's being turned on now, and there you go. Here's some results. Once again, we can look at it later, but everything was the substantial reduction in particle counts and particulate matter. And here we go in a curling club. Sorry, Canadian roots. They wanted to do two things. They wanted to improve the distribution of the air on the ice pad surface and filter it and blow it across in a more laminar flow in order to reduce the K factor for the air changes calculation. And they also had a unit in their bar and conference room. There's we did this by installing some some projection nozzles that were designed to throw the air in a laminar flow 45 feet. It turns out it went about 65 feet without interruption. Obviously, the airspeed slowed down. And here is someone from the curling club talking a little bit about the product. I hope you can hear that. Or you guys all hear that, Kimberly?
Unfortunately not, no.
Okay. Well, his name is Fred. He's a wonderful guy, and he's an engineer, and he talks to this and some of the systems that we put on. So I'll just leave it for everybody to review. He offers some great insight. Okay, so you can see some of the reductions we've had. Almost the numbers in the bar area were already quite low, so it wasn't that difficult to get to some really low levels. But we did have an overall 66% reduction in particle count. And this is his bar area. I would determine this is not as effective. You can see there's still a lot of mixing going on here. They're planning on returning some of these pipes, or rotating some of these pipes and having some distribution duct on there, but it gives you kind of an idea. Not everything was great. This air just rolled right across the ceiling, as you can see. And the goal really would have been to have this air come across the ceiling and gently fall like rain. Here's another model showing the, or simulation showing how the air moved. And I'm just going to skip by some of this stuff. And then there was the bar application. And that was about it. I hope that's helped. Sorry for the communication challenges there. Any questions, or am I a little too early, Kimberly?
Yeah, you're still fine. You're sorry, I made you
Okay,
nervous with the 10 minutes.
that's okay.
You still have 4 minutes, 5 minutes. And we're holding the, well, there is, since you're right here and you're done, I will, we have questions for the panel, but there are some directly to
Sure.
your presentation here. So there's a question about, you know, the idea of mitigating near field effects. So in quite a few super spreader events, been mentioned that the fans are blowing on the people, specifically in the fitness center, on the exercise bikes, who are exhaling hard and blowing their infected aerosols onto others in the room. So he's asking, you know, he understands the ventilation reduced the concentration of particles in the room, but then what about mitigating the near field effects of the people themselves? So you're introducing fresh air, but then you're blowing maybe dirty
Yeah,
air.
it's a great question. Thank you very much. So our goal with these is always to go for a clean to less clean airflow pattern. So we're always trying to get the clean air into the operator or the worker's breathing zone, and then have it come to the floor at floor level and be picked up, filtered, preferably mixed with outside air, and reintroduced. In this case, you're right, that will push some of the hazards to other people. Sorry, I speak in a world of industrial ventilation more than commercial ventilation in other areas, but it will do that. Really, what should happen in this entire facility to address that issue is that the HVAC system should be ducted where the inlets are all at the floor level, and we're supplying all our air up in the ceiling space. Not terribly difficult to do, but if we can pick the air up at the floor, HEPA filter it right at the floor, blow it back into the return of the system, that will go a long way to addressing your challenge that you bring up.
And I think you answered and thanks. Kevin mentions that, you know, you would still require an N95 respirator or better for near field where there's a risk.
Absolutely.
And I think you answered the second part of the question, but feel free to unmute and we'll move on to the next speaker, because he just was mentioning that you, or the question came around mentioning showing the path of the forced air from the nozzles in the bike room past the occupants to the take-up units. And I think you answered that in your explanation along the floor. So thank you.
Okay.
Excellent.
That's great.
And thanks, Rob. So you're sticking around with us for the
I'll
panel.
stick around and we'll go from there.